All right. Welcome to your lesson on the law of conservation of mass. Um, Before we get into what that is, we got to do a quick review on some stuff we did a very long time ago. Um, that being periodic table and atomic structure. So let's get into it. So the first thing we talked about way back when in August is that if you look at everything on our planet, it's made up of something, whether it be biotic or abiotic, and that something would be atoms. And what atoms are the smallest possible unit of matter. Now, if you go back to what matter is, we said that earlier, matter is anything that has volume and mass. So in other words, it exists. It exists in our real world. It exists outside of your memory, outside of your brain. If you can see it, you can touch it. Even if you can't see and touch it, like you can't touch air per se, or you can't grab air, but air exists. And so all these things are made up of one commonality, which will be atoms. Now, if we're looking at atoms in terms of what they combine, is that atoms can combine chemically. If they combine chemically, they can form a pure substance, being a molecule or a compound. Okay. And for this lesson, we're going to treat these to be pretty much the same thing, because they're going to be joined. They're still pure substances. The only difference between a molecule and a compound is that a molecule is when the atoms are the same. Okay, so one oxygen plus another oxygen still gives you oxygen. Okay, versus a compound is where you have two different elements combining. So a compound, which is the most important word that we're going to deal with right now, is a substance containing two different elements or atoms. Okay, so we looked at that earlier, and this is water. So water chemical form is H2O, which means you have two hydrogen and one oxygen. So because they're different, it's a compound. With this one here, we simply have two oxygens. Because they're the same, it's a molecule or an element, which we can use the word interchangeably here. So let's go through this. So you can tell me molecule, which in this case will be element and or compound or both. Okay, so nitric oxide, NO2, would that be a pure substance in terms of all the same type or different types? Well, this would be a compound because there are two different joinings here. Because we have one nitrogen and two oxygen, that would be a compound, two or more elements combined. Nitrogen gas, okay? It's not nitrogen, it's nitrogen gas. Because it's a combination, we're going to say molecule. CH4, which is methane, CH4. Hopefully you remember your periodic table. C stands for carbon, H is for hydrogen. So we have one carbon and four oxygen. Because of that, that would make it a compound. What about hydrogen gas? Well, we only finding hydrogen inside of it, so hopefully you said molecule. All right, so that's a quick overview of how we're looking at these things. So we're looking at these chemical bonds, and because they're chemical bonds, they're still pure substances. These ones will be found in the periodic table because they're so pure. They only have one type, and these ones would not be found because they're a chemical combination of two or more. Remember, chemical marriage is what we call a compound. So here's your definition on the screen. Now we're not going to get into mixtures, so we won't be talking about heterogeneous or homogeneous here inside this lesson. But understand that everything we're going to talk about will be a compound because they're pure substances. So on your periodic table, there are some things you have to remember to sort of understand this lesson properly. So one is that the periodic table is called the periodic table of elements. So everything that we're looking at here is a pure substance. Now, if you look at if you're looking at your periodic table, you got to remember it's divided into periods and columns, or rows and columns. And your periods go from left to right. So this is period 1, this is period 2, this is period 3, period 4, period 5, period 6, and period 7. Keeping in mind that the lanthanides and the actinides are not separated from your periodic table. They fit into this groove right in here. So don't ignore these down here. Then we have our our basic families or columns: family 1, family 2, family 3, and so forth, all the way to family 8 or 18A. And looking at your periodic tables, you got to remember that any capital letter tells you something. It means it's a separate element. So in every one of these, a capital letter indicates a element. The number at the top is your atomic number. The number at the bottom here is the atomic mass. The key thing to remember that every element that's written as a capital letter is a separate element. Okay, so anytime you see a capital on a lowercase letter, you gotta right away indicate to yourself, oh, that either is a one element or it may be a combination of elements. So if you look here at magnesium has a capital M and a small g. But if you see a lowercase letter, you know that it goes with the capital letter. Boron has one capital. So if you saw B plus capital O, that would be boron and oxygen. If they're both written as capitals, then they're separate elements. If they're written as a capital and a lowercase, like in selenium, Ga, that would make it one element. The tricky thing about this lesson is separating where the elements are and where the compounds are. Here's how you remembered it. Capital letters are all elements. A capital and a lowercase is an element. Two capitals is a compound. I'll repeat that. A capital by itself is an element. A capital and a lowercase is also an element. Two capital letters written together is a compound, two separate elements. So once again, if you look at H2O, H2O we know is the chemical compound for water. Because we have an H and an O and they're both written as capital letters, we know that's a compound. So that's how you keep them separate versus if I had an H over here and an O over here, you would know that there'd be separate elements. So it's how they write it. If you're seeing two capital letters written and there is no mathematical symbol in between them, then they're a compound. If I say H plus O, there are two separate elements. If I say H2O and there's no plus sign, there's no equal sign, you now know that that's one simple compound. The common compounds that they normally show up on your test over and over and over again: water, carbon dioxide, table salt, hydrochloric acid, baking soda, methane, ammonia. If I were you, I would memorize these ones. These are the only ones you will see over and over and over again, because these are the most common chemical symbols used in grade 8. Excuse me. So if we're looking at water, H2O, sugar or glucose would be C6H12O6, carbon dioxide, CO2. Once again, do you see how they're writing it where there's nothing in between the C and the O? That's how you know it's a compound. NaCl, sodium chloride, or table salt. There's nothing separating this, and so they're so closely bonded they're a chemical marriage. Bleach, which is sodium plus some chlorine plus some oxygen, but once written together, is now bleach, and so that would be a compound. So if you're looking at here, these are the common elements that you're required to sort of understand as you go through this lesson. They'll make your life so much easier. So make sure you have a screenshot of this page. This should have been your notes from earlier in the year, but I know a lot of you guys don't have your book with you right now. So screenshot it, write it down, whatever you need to do, and that's really going to help you in this lesson, having this little cheat sheet along with you. All right, so let's get into it a little bit more. Let me adjust this. So if we're looking at what this means, anytime we do an experiment, the law says, law of conservation of mass is matter cannot be created or destroyed. You can only change from one form to another. That's something I've repeated in class multiple times. And a simple way of saying that would be whatever you start with, you must end with. Okay? You cannot create things with a thin air. Whatever you put into your cake, you had to put the ingredients in. If you wanted a chocolate cake, you got to put some cocoa or some chocolate into the cake batter. If you wanted vanilla ice cream, well, you got to put some vanilla beans or some vanilla extract into the ice cream to end up with what you want. You can't start with chocolate and end up with strawberry. That's not how chemistry or matter works. And so whatever you start with, you're going to end with. That's what this law is pretty much saying. Now, in trying to figure out what these things are, there are two other vocabulary words besides elements and compounds you have to be aware of. The first one here would be the word subscript. Now, the word sub or the prefix sub means under. So under, and the word script means writing. So it directly translates to underwriting. Okay? And so your subscript is the number they write behind the element, and they write it very small. They write it under it. So look here at where your chlorine is. So the example here is that Cl2. Now, I just told you that anytime you see an uppercase and a lowercase letter, you know that that's one element. But if they're writing a 2 behind the element chlorine, that 2 indicates that how much atoms there are in that element, in that compound, or molecule. And so Cl2 means you have 2 chlorines. Okay? There are 2 of them. If you're looking at the water once again, we have the H. There's a 2 after the H. Now here where it gets tricky, so please pay attention here. The subscripts only apply to the elements they are directly behind. The subscripts only apply to the elements they are directly behind. So this 2 only affects this hydrogen. This 2 has nothing to do with the oxygen over here. Now, in chemistry, I told you guys at the beginning of the year, there's only one number we never write, and that number is 1. And so you have the oxygen right here, and there's no number behind it. If there's no number behind it, that means there's only one of that element. Okay? The 1 is understood in chemistry. We don't write the number 1. The 1 is understood. So H2O literally means we have 2 hydrogen and 1 oxygen. This 1 comes from the fact that, hey, even if we didn't write it here, we know that 1 is there. Okay? Once again, I hope you guys, that's a bit tricky. Okay? So the subscript only applies to the element it's directly behind. Now, don't worry about the brackets here. We'll get back to that in a second. Next lesson. Let's skip down here to the word called coefficient. Okay? So a coefficient is a number written in the front of an element, and it has the effect of multiplying everything behind it. It multiplies. Okay? Your subscript only tells you how much they are. Your coefficients, they multiply. Okay? So let's look at it in real life here. So if I have 3C, hopefully you remember that C means carbon. Now, if you look here, there's a number we're not writing right here. Okay? Now remember, we're not writing the 1, but the 1 does exist. So we're saying 3 times 1 equals 3. That's where the 3 comes from. Because if we said that was a 0, 3 times 0 would be 0. So the subscript, which is not there, is always multiplied by the coefficient that is there, that may or may not be there. It's multiplied by the coefficient. So 3 times 1 equals 3. Over here we have 3Cl2. Once again, that's an L. Remember, if we write a 1, we don't write 1s. If we were writing an I, it would be double stamped. So an I in chemistry always looks like this. Okay. That's how that would look like. Okay. So if you don't see that, that's going to be a lowercase L. Okay. So keep that in mind for me. So if we're looking at this, is that we have 3 times 2 equals 6. Okay. That's where that 6 comes from. So 3Cl2 literally in chemistry means this. You get a Cl and it's joined to another Cl and is joined to another Cl. Now, because scientists are lazy, they write a Cl2. Let's look at this one here. We have 4H2O. Now, the coefficient multiplies everything behind it. So 4 times 2 is 8, and 4 times 1 is 4. So that's how we actually got this here. Okay, so we'll go into this in the next lesson, next video. This one's a bit long, so I want you to really look at this before we get deeper into it.